Hi there everyone. Welcome to the video lecture series on complex integration. In this video lecture we shall see a new kind of a question where we are given this following integral to integrate, okay, over the semicircle given in this manner. Okay, so here the curve of integration is semicircle. So let us see how to handle this kind of question. So our first thing is that we are going to understand the circle, the semicircle given to us, or the curve that is given to us. So let us write down the step 1. So step 1 is understand the curve. Now here if we see the curve which is involved, that is given to us by words, semicircle z equals to 2 into e to the power I theta, and theta is 0 to pi. Okay, so one thing which is very easy over here, that we do not have to struggle to find the limits for theta. It is already given in the question. So here z is equals to 2 into e raised to I theta when we see, and 0 less than or equal to theta less than equal to pi. Now see, when we have this given to us, we try to recall the substitution that we used to do. The substitution that we are expected, I'll just write here, the substitution is z equals to z naught plus r into e to the power I theta, right? This is the substitution. Now compare this substitution with what it is given over here in the form of the equation. So that is, if we compare here, we get z naught is equals to 0. Okay, or you can even call it as 0 plus 0I. Also r is equals to 2. Alright, we get that. Now from this substitution we can also understand that now limits are already there, right? Now from this we can find dz. Okay, therefore our step number 2 comes into the picture. Step 2 is find dz. Okay, so step 2 will become now, because here we do not have to do any explicit substitution, so I will directly write now dz by d theta. I can write it as 2i e raised to I theta. Therefore, dz is equals to 2i e raised to I theta d theta. Okay, this is what we can get. Now we have got the value for theta, right? Or let me just label them, what all things we have. We have got from this first, here we have got the value for theta as well as the substitution is given in the question. We have got this second thing also. Now we will simplify the function. Okay, let us see what happens on simplification for the function. So let us take up step number 3 is simplify function. Function f of z. So here our f of z is already given to us as z minus 2 divided by z, right? So now instead of z minus 2 upon z, what we can write is, we can write 2 e raised to I theta minus 2 divided by 2 e raised to I theta. And we got this because we are substituting for z equals to 2 into e to the power I theta from the uh, given equation number 1. Okay, so we'll call this equation number 3. Okay. Here we'll call this as 3. Now step number 4 we come across. So that is going to be step number 4, solve for I, capital I, the integral, okay? Or solve for integral, let me write here clearly. So let us solve now. So I is equal to integral f of z dz over the curve C, whatever curve is given to us. So now we have got our function. Always write the function first, later on you go for the limits. We are given 2 e to the power I theta minus 2, okay, divided by 2 into e raised to I theta. We got this from equation number 3. Now dz we have got it from equation number 2. It is going to become 2I e raised to I theta d theta. Now limits for theta are going from 0 to pi. So let us simplify this. What happens? Now let us see what all thing gets cancelled. So we can see here, I'll just take up, let me take up some green color. Now we can see here this 2 gets cancelled. E raised to I theta gets cancelled, right? So what is remaining is a constant I. So I'll take that constant I outside and keep it alone. So therefore capital I is equal to small I times integral 0 to pi, okay, 2 e raised to I theta minus 2 d theta. Now this is what we have to integrate. So let us see what happens here. I times, now the integration here is 2 times e raised to I theta divided by I minus 2 times theta. Okay, when you integrate you will get this. So and the limits are going to go from 0 to pi. Therefore I equal to, okay, let me just write it here carefully. I equal to, yeah, now you just plug up the value. Here you will get 2 e raised to I pi divided by I minus 2 pi minus I times 0. Now this 0, when you substitute here, you get 2 upon I. Okay, this is 2 upon I. Just a minute. Here, 2 upon I. Okay, minus 0, right? 2, here you will get 0 because 2 into 0 you will get. Now let us solve this. What do we get? So on solving we get here is therefore capital I equal to, now this I will get cancelled, okay, and e to the power I pi is minus 1, okay. So we learned in our previous video lecture, so this is going to be minus 1. This will become 2 I pi, or I'll write pi I, okay, and then we have here coming it as minus of 2. So my final answer for this will become minus of 4 and minus of 2 pi I. This is the final answer. So I'll just put it a box over here in the top where I'll just write, therefore I equal to minus of 4 minus of 2 pi I is the final answer. I'll just keep it clear a bit. So it is 2 pi I. Yeah, this is the final answer. I'll put a, let's put now a blue box. That I like the final answer. So this is the final answer. Okay. So this is how here it is done. So be a little bit aware how these equations are to be handled. Only thing is, main part is once you understand the curve and the limits, the things settle down. Okay, so steps are almost the same everywhere. You have to find for dz, then find for the function, then the limit you have to take care from accordingly whatever the curve is given, and then solve for the integral. Okay, so this is about how to solve the line integral or a contour integral when our contour is a semicircle. I hope you like this video and you have understood the concept of solving. Please hit like button and share and subscribe my channel, and share it with all your friends, those who find this topic important and they have in their syllabus for their exams or any other uh, concept which are there for them. So I hope you like this topic, and please hit like button. Thanks for watching the video. I'll see you in the next video lecture. Till then, signing off, it's Mayur Gohil. Keep solving good amount of mathematics.